Right, here's a couple of Fisher projections that we want to figure out what the relationship is between them. You can go ahead and see that you do have chiral centers here and here. Also, kind of orient yourself along your main vertical backbone, which is this 4-carbon chain. Okay, but in order to compare these, you really want your backbone to be the same orientation in both. Meaning, if I take this first one and I number starting at the carbon closest to the OH, we're going to have 1, 2, 3, and 4. If I number the second one, but I want my numbering to be consistent, so I start on the carbon down here as 1, that way carbon 2 has the OH, 3, and 4. Well, here my numbering's upside down. In order to compare these more easily, I want to spin this one around on the page 180 degrees to bring this carbon up to the top, carbon 1, to match this carbon 1. Okay, and you are allowed to rotate Fisher projections 180 degrees, and it doesn't change the identity of the molecule. Just don't do a 90-degree rotation because that can give you the enantiomer. So if we spin this one 180 degrees, now we have this carbon that I've highlighted in orange up at the top. And then if we number this, 1, 2, 3, and 4. Okay, but on carbon 2, this OH, you spun that around to the left 180 degrees, that OH ends up right here on the left side now. And then hydrogen's on the right. And then on carbon 3, the chlorine ends up on the right side, hydrogen on the left. So now if you compare this first one and this one, you can see on carbon 2, the H and the OH get swapped or inverted. On carbon 3, the Cl and the H get swapped or inverted, or maybe you can just see the mirror image between the two. So these are a pair of enantiomers.